بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضات لغات، أهلا بكم. النهاردة هناخد مراجعة في الديناميكا، ودي المراجعة الثانية في الديناميكا. وطبعا علم الديناميكا علم مهم جدا جدا، والمراجعة دي هامة جدا لأن هي بتضم المنهج بتاع الديناميكا، لأن طبعا احنا عارفين في حاجات جديدة نزلت لنا في تكامل وفي تفاضل الدوال المتجهة، ودي مهمة جدا جدا في علم الديناميكا. Welcome my dear student in our math program for secondary 3. Today we are taking second revision in dynamic. Dear student, look at the first example. General revision in dynamic 2. The first example, dear student, the power of a train's engine is 504 horses. And its mass is 216 tons, moves on horizontally railway. And its maximum velocity against resistance equivalent to 5 kilogram weight per each ton of the mass. Find the maximum velocity in kilometer per hour. Dear student, the required maximum velocity in kilometer per hour. At maximum velocity, dear student, we know that F the force equal resistance, R equal 5 times 9.8 times 216 Newton. Then B equals F times V. Then F equals 504 times 735, this left hand side, equals 5 times 9.8 times 216 the force times V velocity by using division. Then velocity equal 35 meter per second. After that we convert it by using 13 over 5, then the velocity equals 126. Another example. Rubber ball of mass 200 gram is laid to fall on horizontal surface up from a height of 90 centimeter. To rebound up to height of 40 centimeter, calculate using kilogram meter per second unit the magnitude of change of momentum of the ball as result of impact. Dear student, look at the solution. Look at, dear student, the body, the first V naught equals 0. G gravity force 980 centimeter per second square. The distance is 90 centimeter. When the rubber is impact on the ground and rebounding, S becomes 40, G 980, but V final velocity equals 0. In the opposite graph, we know that the first direction in C direction. The rubber is drop down. C is the vector direction of motion. V naught becomes 0. G from given 980 centimeter per second square. The rubber body from distant 90 centimeter, after impact it return with G 980 and the distance is 40. After velocity, final velocity is 0. Look at, dear student, from V square equal V naught square plus 2GS. Find V1 square, the velocity when the body fall. The velocity V1 equals 420. This velocity when the body or the ball is full, it moves with velocity 420 centimeter per second after rebounding. Then, in the case of rebounding, since by using the same rules, v squared equal v naught squared plus 2gs, v squared equals 0. This final was its reach maximum height. Maximum height equal 40. Maximum height means v equals 0. 0 equal v squared, v naught squared minus 2 times 9.8 times 40. Then v2 equals 280 centimeter per second. The change of momentum equals delta h equals mv2 minus v1 inside bracket. The mass is v m times v2 minus v1 by using substitution. 200 the mass of the ball over 1000 in kilogram equals v2 minus v1. v2 negative 2.8, v1 4.2 in c direction equals negative 1.4 c direction. This is the change of momentum. The momentum is 1.4 kilogram per second. Another example. Force of magnitude 10 newtons act on a body at rest of mass 8 kilogram to move it in its direction with uniform acceleration. Calculate the distance traveled after 12 seconds and its velocity. Solution. Look at the student. F equals 10 Newton, V naught equals 0. Then M equals 8 kilogram, T equals 12 second. The equation of motion of the body equals MA is MA equal F. MA, M equal 8 times A equal 10, A equals what? A equals 10 over 8 or 5 over 4 meter per second. V equal V naught plus AT, the first rule of motion, by using V naught equals 0, then V equals 0 plus A, acceleration 5 over 4 times T 12, then V equal 15 meter per second. Then by use the second rule of equation of motion, S, the distance equal V naught T plus half A T square. Then by substitution, V naught equals 0, S equals half times 4 over 5 times 144 T square. Then S distance equal 90 meter. Another example. Body of mass 400 gram moves with velocity v vector equal 80 vector, 80I vector plus 60J vector, where the magnitude of v vector is in centimeter per second. I and J are two fundamental units vector. Find the kinetic energy of this body in joule. The required kinetic energy of this body in joule. Solution. Dear student, we know that V equal norm V vectors equal square root coefficient of I power 2, 80 power 2 plus 60 power 2 under square root equals what? 100 centimeter per second. This is the velocity. Then we have M mass equal 400 divided by 1000 to convert in 0.4 kilogram. What is the kinetic energy? T, its symbol of kinetic energy, equal half mv square. What is the m is mass? What is the v velocity? By substitution, then T equals 1 over 2 times 0.4 times 1 square equals 0.2 joule. Then kinetic energy is 0.2 joule. Another example. Bullet is fired from cannon with velocity v vector 70 I vector minus 240 j vector, where I and j are two fundamental unit vector. The norm of v vector is measured in meter per second. If the kinetic energy of the bullet is 4.375 times 10 power 5 joules, find the mass of the bullet. Dear student, look at the solution. At the first, we find norm of the velocity. What is the norm of the velocity? Equals square root 70 square plus 240 square, coefficient of I plus coefficient of j equals 250 meter per second. This norm of the velocity equal 240 meter per second. Since kinetic energy, its symbol T equal half mv square, then by using the given, kinetic energy is 4.375 times 10 power 5 equals half times m times 250 square. By using operation of division, we find the m equals 14 kilogram. The mass is 14 kilogram. Since T equal mv square, by using half times 0.4 times 1 square equals 0.2 joule. Another example. Bullet is fired from cannon with velocity 70 I minus 240 j. I and j are two fundamental vector. The norm of v is measured in meter per second. If the kinetic energy of bullet is 4.375 times 10 power 5 joule, find the mass of bullet. Look at the solution. By using v, norm v equals square root 770 power 2 plus 240 for all power 2 to find the velocity of v 250 meter per second. Then we know that T equal half mv square, then m equals 14 kilogram. Then T equals half times 0.4 times 1 equals 0.2. Another example. The opposite figure illustrates action of variable of the force. Force F is distant. Measured in Newton, a body moves displacement of magnitude S, measured in meter. Find the work done by this force when the body moves. Number 1, from S equals 0 to S equals 8. Number 2, from S equals 8 to S equals 12. The work done, dear student, look at what is the work done when of the body when S equals 0 to S equals 8. The first required. Second required, from S equals 8 to S equals 12. Number 3, from S equals 0 to S equals 12. Number 4, from S equals 5 to S equals 10. Solution. Look at, dear student, the work done when s equals 0 to s equals 8 equals integration or definite integration from 0 to 8 f ds. What is the integration from 0 to 8? Yes, area of what? Trapezium. Look at, dear student, area of trapezoid or trapezium OABC equals half multiply sum of two bases times height equal half times bracket contains 8 plus 4 times 6. Answer is 36 joule. Dear student, in this example, we know that the integration from 0 to 8 of f ds represented by area of trapezium of OABC. What is the area of trapezium? Half sum of two bases times height. What is the two bases? AB and OC. OC equal 8, AB equals what? 4. Then the height is 6. Then when find the area of trapezium or the work done from 0 to 8 equals 36 joule. The work done from S equal 8 to S equals 12 equal area of triangle, or integration from 8 to 12 FDS represented by negative area of triangle CDE. Why? Because the triangle under straight line of S. Then area of triangle half base times height. Base equal 4, height equal 6, negative half times 4 times 6 equals what? Negative 12 joule. The work done from S equals 0 to S equals 12 by integration from 0 to 12 FDS. Then we take sum of two areas of a trapezium and triangle. But the trapezium, the area of trapezium above straight line S, but area of triangle down straight line with negative. Then area of trapezium minus area of triangle equals what? Equals 36 minus 12 equals 24 joule. Look at the work done from S equal 5 to S equals 10. Look at, dear student, from S equals 5 to S equal 10 equals definite integration from 5 to 10. From 5 to 10, definite integration FDS. What is the expression or what is the area represent definite integration from 5 to 10? Excellent student. The area of trapezium when its base, the first base 1, second base is 4 and its height 6. And we take area or half area of triangle CKD, base equal 2, height equals 6. Then when we find work done, the body from 5 to 10 equals area of trapezium BXYC minus area of triangle CDK. Then what is the area of trapezium? Half sum of two bases times height. Area of triangle half base times height. Base of triangle 2, height equals 6. Negative, why? Because area of triangle under straight line S. Then half times 4 times 6 equals 12 minus 6. Answer is 6 joule. Dear student, in this example, the work done, we find the work done by using definite integration from 0 to 12 and from 5 to 12 and from 5 to 10. From 5 to 10, the work done is definite integration 5 to 10. This represented by area of trapezium and the area of a triangle. By using area of trapezium, this trapezium, the first trapezium or green trapezium, its base 4, its base 3 and 1, its height 6. Then by using half times 4 times 6 minus half times 2 times 6, the area or some area equal 6 joule. Then the work done from S equal 5 to S equals 10 equals 6 joule. Another example. Sphere of mass 3 kilogram moves on a straight line on a smooth horizontal plane with velocity 210 meter per second. It collides another sphere of mass half kilogram at rest. They formed one body after collision. Find their common velocity after collision directly. Then calculate the lost kinetic energy due to collision. If the common body moved under effect of constant resistance, make it at rest after covering distance 2 and 4/7 meter. Calculate the magnitude of this resistance in gram watt. Solution. Since, dear student, M1 V1 plus M2 V2 before collision equals M1 plus M2 inside bracket times V after collision. By using substitution, then 3 times 210 plus half times 0 equals 3.5 sum of 2 mass times V. By using velocity, V equals 180 centimeter per second. The kinetic energy before collision equal half M1 V1 square plus half M2 V2 square. By using substitution, half times 3000 times 200 square V1 plus half times V M2 500 times 0, answer is 6.615 times 10 power 7 H. Kinetic energy after collision is half times 3500 times 108 square equals 5.67 times 10 power 7 H. Then the lost kinetic energy subtract from kinetic energy before and kinetic energy after collision. This is 6.615 times 10 power 7 minus 5.67 times 10 power 7. Answer is 0.945 times 10 power 7 erg. Then the lost kinetic energy is the kinetic energy after collision minus from kinetic energy before collision. We find M1 V1 square and M1 V1 dash squared, then find, subtract from kinetic energy to calculate the lost kinetic energy after collision. with respect to motion of the common body after collision, v squared equal v naught squared plus 2as. By using substitution, then v squared 0, v naught squared 180 squared plus 2 times a times 1800 over 7, then acceleration is negative 63 centimeter per second square. Since the resistance equals MA, negative R equal MA, by using M equals 3500 times negative 63, then resistance equals 220,500 dyne. By using divided by 980 to find resistance with gram weight, resistance is 225 gram weight. Look at another example. Body moves in straight line such that acceleration of motion is given as function of time t by the relation A equals 2t minus 6, where A is measured in meter per second square unit and time t in second. Calculate the momentum of the body in the time when t more than or equal 3 and smaller than or equal 5. If the mass of the body is 8 kilogram. Solution. Look at the student. Delta H equals K integration, different integration from T1 to T2 A dt. Delta H equals K constant 8, 3 integration from 3 to 5, A is acceleration, 2t minus 6 is relation by time t dt. Then what is the integration of tt minus t equals t squared minus 6t. After that, substitution about t equal 5 and about t equals 3, then subtract, then delta H equal 32 kilogram meter per second. Delta H, dear student, K integration or definite integration from T1 to T2, acceleration A respect to time t, then 8 integration from 3 to 5, 2t minus 6 dt equals t squared minus 6t multiply 8. After that, by using substitution about t equal 5 and about t equal 3, then delta H equal 32 kilogram meter per second. Dear student, by the end of the lesson, I am very happy to spend such time with you. Don't forget, math simple, think, work, produce.